So good morning students. Today I am going to explain about group 13 elements, boron family. So already in the previous video I explained about the p block elements, what are the different groups are present and what is its oxidation state, everything. Okay. And in the boron family you see boron, aluminium, gallium, indium and thallium. These are the elements are present in the boron family. In this group, 13th group, except boron, remaining all the elements, aluminium, gallium, indium, thallium are metals. Boron only non-metals. So this is one important 2-mark question. Why boron exists as a non-metal in the 13th group? Because of it's smaller in size and have high ionization enthalpy and also have high electronegativity. So it is non-metallic, showing what? Non-metallic character. Whereas aluminium, gallium, indium and thallium are metals. And another one important question in this group is define inert pair effect. What is the meaning of inert pair effect? Let us see that. See, in the boron family, otherwise in the 13th group, boron, aluminium, the general oxidation state is +3 because you see the electronic configuration of boron, aluminium, gallium, indium and thallium. All the elements are having 3 electrons in their outermost shell. That means Ns2Np1 is that is the valence electrons, general electronic configuration of the 13th. So in the case of boron and aluminium, +3 oxidation state is more stable. Whereas in the case of gallium, indium and thallium, comparing with the +3 oxidation state, +1 oxidation state is more stable for these all the 3 elements. Because so even in gallium, indium and thallium, it has completely filled d orbitals. You can see gallium, it has 3d 10 electrons and indium 4d 10 electrons and thallium 5d 10 electrons are there. And thallium also having 4f 14 electrons. Since the d orbital electrons as well as the f orbitals electrons are showing very poor shielding effect, even the outermost valence electrons are easily or directly attracted by the nucleus. Therefore, in gallium, indium and thallium, whatever the valency s orbital electrons, 4s2 and 5s2 and 6s2 orbital electrons are reluctant to involving in the chemical reaction. Only the p orbital electrons only it involves in the chemical reactions. Therefore, this effect is called as inert pair effect. Once again I tell you, boron, aluminium, gallium, indium and thallium, comparing these all the 5 elements, for boron and aluminium +3 is the common oxidation state. Even for gallium, indium and thallium also the common oxidation state it is +3. Apart from +3 oxidation state, it is more stable only when it shows +1 oxidation. Okay. What is the reason? Because of inert pair effect. What is inert pair effect? On moving down the group from boron to thallium, even the filled d orbitals as well as filled f orbitals are showing very poor shielding effect. Due to that one, the valency s orbital electrons are reluctant to involve in the chemical reactions, and this effect is called as inert pair effect. And now, so today, so we are going to see the boron, what is the reactions of boron and how it reacts with one another. Let us see. Boron group, in boron, when it reacts with chromium, it forms chromium boride. Chromium boride, I have written the formula CrBn. The N, it depends upon the number of boron atoms combined with the chromium. When boron combined with chromium at 1500 Kelvin, it forms chromium boride. Similarly, when it reacts with the non-metals like nitrogen, it gives boron trinitride. So in this compound you can see the +3 oxidation state of boron, as well as when it combined with oxygen, it gives boron trioxide at the temperature of 900 Kelvin. When it is treated with the halogens like fluorine, chlorine, bromine and iodine, it gives BX3. It means BF3, boron trifluoride, BCl3, boron trichloride, Bi3, boron triiodide. Okay, so now how it reacts with boron? Reacts with acid and alkali. With sulfuric acid, it gives boric acid and sulfur dioxide gas will be released out. When boron reacts with sulfuric acid, it gives boric acid and sulfuric acid. Boric acid formula H3BO3. Similarly, when it reacts with the nitric acid, it gives boric acid and it releases nitrogen dioxide gas. With the sulfuric acid, sulfur dioxide gas will be liberated. With the nitric acid, nitrogen dioxide gas will be liberated. When it reacts with an alkali like sodium hydroxide, it gives sodium borate. It gives what? Sodium borate. So these are the chemical properties of boron. Now, what are the uses of boron? Boron 10, that is used in moderator in the case of nuclear reactors, because so it's having the capacity to absorb the neutrons. So the slow moving neutrons in the nuclear reactor can be absorbed by the boron 10. Therefore, it is used in the as a moderator in the nuclear reactors. As well as amorphous boron also, it is used in the rocket fuel. And B2O3, boron trioxide, that is used in the manufacturing of Pyrex glass because it can withstand very high temperature. And boric acid as well as sodium, borax, Na2B4O7 is nothing but that is what? Borax. So these are used in eye drops as well as what? Washing powders. So these are the important uses of boron. Now, even for one word from these uses, any one word can be, any one point can be asked. Okay, remember it. And then next one, borax. Borax, the formula is Na2B4O7 and it contains 10 water molecules. If borax have 10 water molecules, then that is called as prismatic form. It is called as what? Prismatic form, and it has the tetranuclear units. So what is the tetranuclear units? B4O5OH 4 times it carries what? 2 negative charges. So this is the tetranuclear units, and that is present in the prismatic form. What is prismatic form? If borax contains 10 water of crystallization or 10 water molecules, then that is called as what? Prismatic form. If the borax, if it contains only 5 water molecules, instead of 10 water molecules, if it has only 5 water molecules, then that is called as octahedral borax. Octahedral borax, otherwise jeweler borax. Remember it, the difference between the prismatic form and also jeweler borax. Prismatic form, borax, it contains, there are 10 water molecules, whereas in the jeweler or octahedral borax, so it contains only 5 water molecules. At the same time, the anhydrous borax is called as what? Borax glass. So its formula Na2B4O7. The anhydrous borax is what? That is the borax glass. Okay, so how borax is prepared? Borax is prepared from its ore, columnate. The columnate, its formula is Ca2B6 and O11. Columnate, this is the ore from which the borax can be prepared. So when the columnate ore, the powdered form columnate ore is treated with sodium carbonate solution, and it forms borax and calcium carbonate and calcium hydroxide. So borax is prepared from columnate ore. Columnate ore, when it is treated with the sodium carbonate solution, and it decomposes to form borax. Okay, and now you see the chemical properties of borax. Chemical properties of borax. Borax, when it is treated with hot water, it forms boric acid and sodium hydroxide. So here one important reasoning question is there. Sodium hydroxide and boric acid will be formed when borax is present in, otherwise treated with hot water, because when borax is present in hot water, it is alkaline nature. Why it is alkaline nature? Due to the presence of the sodium hydroxide and one acid, boric acid. Okay, and borax, when it is treated with hydrochloric acid, it gives boric acid and sodium chloride. When it is treated with sulfuric acid, it gives boric acid and sodium sulfate. So try to understand the difference between how the hydrochloric acid reacts with the borax and sulfuric acid reacts with the borax. So in these two